Now, probably you are aware of the fact that completely empty, just half filled and completely filled sublevels will have some extra stability. For example, if we consider d block elements, the maximum number of electrons will be 10 in the d sublevel, and so any element or ion, as the case may be, having the electronic configuration d0, d5 and d10 will have some extra stability compared to other configuration like d1, d2, d7 and so on. The same is the case with lanthanides and actinides also. Lanthanides 4F sublevel is being filled. Similarly, actinides 5F level is being filled with electrons. Similarly, we notice F0, F7 and F14. These three configurations for any element or again the ion, as the case may be, will have extra stability. Therefore, if any element nearing the middle of the series will try to get extra stability by adjusting its configuration. Or in other words, we can say, if we consider d block elements, the difference in energy level between d and s is somewhat very short, very small. And because of this, the configuration adjustment between d and s electrons is possible. And we also notice the transition metals are capable of forming different oxidation states. Similarly, 4F and 5F series of elements, namely lanthanides and actinides, they are also capable of forming different oxidation states. But as a sort of a remarkable property, I can say, in the case of lanthanides, +3 oxidation state seems to be the common oxidation state. Usually one question is asked, why is it was found very difficult to separate the lanthanide elements when these are present, all of them are present in a particular solution? And the answer is because of the common oxidation state +3 for all these lanthanide series of elements. All the 14 elements will exist in +3 oxidation states. And as time passes on, the scientists notice that several experimental techniques in the form of ion exchange techniques, chromatographic techniques, these were found to be very helpful in the case of the separation of lanthanides and also separation of the individual members of actinides, as the case may be. If we try to separate the individual members of lanthanide and actinides using chemical techniques, a single step will not lead to the desired result, whether it is crystallization or precipitation or complex formation, etc. We notice almost all the lanthanide ions which exist in +3 oxidation state will precipitate completely. Not a single ion will precipitate as a preferential sort of the chemical methods. But ion exchange technique, chromatographic techniques, they were found to be quite useful. And because of these techniques, scientists were able to isolate the individual members of lanthanides and actinides. Now, probably you are also aware of the fact that the names of scientists were assigned for several of these elements. Similarly, after the names of the planets, we have elements like uranium, neptunium, plutonium, etc. Similarly, after the famous scientists, we have lawrentium, nobelium, mendelevium, fermium, and so on.